Hello everyone, I am Xiao Gang. Welcome to our second chapter. Today, we are going to talk about understanding the engine's architecture. First, let's briefly discuss the learning method, how you should study. Some people prefer top-down and some prefer bottom-up. Actually, we will cover both. We will start with the high-level concepts for everyone, which is our second basic architecture diagram. We will actually start by explaining this high-level chain to everyone. Then, our third one is bottom-up. We will directly talk to everyone about the code standards and coding specifications. So these two diagrams are very important. After our first chapter on the development environment, okay, good. The driving software engine is very powerful. Its current source code should have tens of millions of lines. Previously, Unreal Engine 4 was probably several million lines. We also wrote a tool before to test it out. I will also share with you how this tool was written later. So how should we get started? You need to set up your own learning framework and then structure your knowledge. Well, first of all, the study method I recommend. First, you should have a conceptual understanding. Then you play around with the blueprint. And it would be best if you learned some C++ and then combine it with our UEC+, just connecting the entire workflow. And once this workflow is connected, make your own demo, a very basic demo. Don't use too many plugins or too many non-native engine modules or advanced engine modules. Don't use 都实验. You just need to implement the most basic walk, run, and jump. Implement Pende, a damage exchange mechanism. Implement game startup and game shutdown. Use these components to set up the core gameplay architecture. Finally, you can build upon the demo. Then you can continuously add advanced features for expansion. Then you can proceed to develop further. Just choose a module or area that interests you. Which field should you pursue? Generally speaking, if you choose a field that you personally like, it will be employable. Specifically, you might work on animation, or perhaps audio, or client-side development, or perhaps editor tool development, and so on. It depends on which area you are interested in. Next is another section, through continuous learning. Of course, this entire process is actually very long. It requires at least half a year. Personally, I think it requires at least 6 months to a year. A year would be better because of the high difficulty of learning. Deciding like this, if you learn too quickly, you might not be able to reach the level of practical operation. Because for many things, you only know the click here. But what thoughts are guiding your click? Why click it? Okay, so let me say one last thing, which is, since you work with Unreal Engine, you should at least play an Unreal Engine game. Only after playing this game and experiencing it, you will understand about this thing we made. It was originally designed this way. For example, like when you play in Unreal Engine, you can play cooperative roles. You can play Fortress Knight. You can play Black Meat, Wukong, and then you'll know. Then with your Jinshu controller, it is called the input system in Unreal Engine. In the old version, it was called the input system, and in the new version, it is called the enhanced input system. Then our character, it casts skills. For example, QWER. This is the skill. For this skill, the entire set of keys, then cast the skill, then generate effects, then damage calculation, then enter cooldown, and then these things. So it's called the game ability system. It's called gameplay ability, right? And regarding these, before entering the game, including your defeat CG or the game ending CG, then these can be done using our sequence, extracting them one by one. Overall, what you are doing is expanding and learning based on our own experience. So good. Before we formally introduce the content of this section, we mainly introduce this module project. What is the relationship between these sections? Okay, so this is mapped into our engine. So first, we will detach from this engine. Detaching from this engine, we depart from Unreal Engine. Let's first discuss a general game engine. For example, there is Unity on the market, there is UE, there is Cocos. There are also 2D, some are 3D. Right? So what is a game engine? It's an engine that gives you tools to work with. So it must have many functions. So how are these functions made? First, we'll recommend a diagram to everyone. First, we open this website. How do I search for this URL? It's actually very simple. You search in this spot. This thing. Then we put it here. There is a picture here. It's this picture, right? I won't go into detail about this part. Right. This area has many panels for animation, rendering data, sound effects, and tools. And this is everything related to the engine's core functionality. These features are extremely advanced. And here you can go download it from this place. You'll need to log in first, then go download it from this place and you can get the image. Then everyone can go into Games 104 to deeply study our game engine technology. What we are mainly talking about here is the Unreal Engine. Okay, so after recommending this to everyone, we will erase it. Then let's first look at a general engine. What is its general architecture? Okay, so this diagram might be a little lively. Let me open the original diagram I made. Just wait a moment. Then we open our specialized I/O. We specially use this specialized I/O to draw some flowcharts for everyone. Schematic diagram, and it has many layers, doesn't it? Just like our world architecture. How is our world structured? It's layer by layer from atoms and molecules. These layer by layer from single-celled to multicellular organisms, and then to insects like these, non-species life forms, added layer by layer. So let's start by looking at the lowest level. The lowest level is this diagram of ours. This was taken from the second version of this game engine framework. Yes, we specifically found this kind of image for everyone back then. Okay, you don't have to worry that this is too complicated, because actually we won't use so many layers. We only use a few of them. That's enough to create our game. So first, it's the hardware, our CPU and GPU, right? Our memory and hard drive, that is the lowest level. And then hardware. So what we need to use from the hardware are drivers. The most common one is our graphics card driver, right? Or graphics card drivers, or some motherboard's BIOS, right? Or things like graphics cards. These drivers, these pieces of hardware. And then based on this, we integrated an operating system. Okay? An operating system is like our Windows. It's Linux, Mac, iOS, Android. This is what we usually refer to as the 5 Ns. These 5 Ns are required for currently large-scale standards. This type isn't 3A. Domestic standards. This type of mobile game development, it's about all 5 Ns progressing simultaneously, right? These are our 5 endpoints. Then on the operating system, we needed to use some third-party software development kits because others specialize in it. For instance, if we want to handle audio or handle languages, you can't develop one yourself. When you make a game, you can't make games anymore. Writing an engine and then building your own engine is completely okay. No problem. You build your own engine. You also need to create a set of programming standards and a programming language yourself. This has a bit of, it's too far removed. So some third-party packages, we don't care about these either. Let's just continue going down. The visible DXOBL, a package for rendering graphics, right? There's also STL in C++. STD is equivalent to a standard library, the standard for a universal library. Then finally we reach the platform-independent layer. We need to start focusing on this layer because we are making games. If we are developing for multiple platforms, then we must abstract out a layer to connect different platforms through this layer. So Unreal Engine does this. You develop on Windows, you just follow the Unreal Engine development. After developing it, it automatically wraps a platform layer for you. Then you just need to use the interface of this platform layer. Then within this platform layer, we will deploy to 5 endpoints. These 5 endpoints are Android, iOS, Linux, Windows, and so on. Then they are on different operating systems will require different third-party packages. Marked, choose, weekend, ODX, etc. to render on different platforms, file storage, read and write, and some network access libraries. Because, as you know, the network library on Android and on this computer, the libraries used must definitely be different. Things like sending HTTP requests, etc., right? First, you must detect the platform, right? Your data types are all different. What you have might be, it requires this kind of memory. It's a little bigger. Some need to be a little smaller. So it needs to define a universal data type. We stipulate that at this platform layer, we all use this kind of data type. And then it itself, based on this data type, performs some divisions. And the way of container management is also quite different. This involves memory allocation, right? It's possible that some platforms, you can use a lot of memory, but some platforms in our in-vehicle system or on Android for us. So regarding memory, I'll use the CPU again. It has certain limitations because it has to prioritize safety. So regarding this area, it is a mandatory requirement for us like our in-vehicle system. If superior, we only do rendering. It's the picture that you render might lag a little bit or might be blurry a little bit. This doesn't affect it. This is so it might give way to these soft sound and also includes reading and writing files. Next, let's talk about networking, including things related to time and also includes threads such as thread allocation or CPU scheduling, right? And then moving up, actually, this is our core system. This set of core systems are all built on a common platform layer. You can see that. Zelly, the word module, or we focus on calling them modules. What exactly are modules? We will discuss later. Modules are actually sets of resources, content, code, and so on. Assertions help us debug and check the code. Unit tests are like block-by-block testing, and these are some commonly used debugging methods. Localization services are our universal language. It's about how you use certain keys to map to 8 languages, right? It's about playing videos, and the common syntax is usually CSV, XML, NJ, CNC, and so on. Designing data, mapping tables, and then our performance analysis. And the engine uses some text file configurations. That is correct. And then randomly, right. And then some reflections. We will focus on UE5's reflections. Okay, and this is a unique identifier, just like our ID card. Okay, this is an I/O. It's reading and writing files. Actually, when we develop later, we will encounter you read a file in-game. It's actually very good. At this point, we will consider our multi-threading, okay? So this area is where we go further up. These are some general ones that our engine has prepared for us, some of the most fundamental module. So based on these modules, we have some core systems. So how do we manage our resources? It's very common. So what resources do we have? We have some 3D model resources, like our FVector and so on. GLB, like some rocks, right? The most common rock, a house, wood, and stuff like that. These are the resources for the model. This is called the model. Model is created in Maya. So the textures are just the maps. Right. And then the material is the one we write in the UV. Right. And then the font is some of the fonts you see. Right. We generally use the engines. Everyone pay attention to this font. It has one thing. You shouldn't use fonts of unknown origin, because once your game is released, people might recognize you because of this font, and they file a lawsuit. Your game might get taken down, and you'll have to pay them money. Google is basically our skeleton mesh, which is a movable character model. It's the skeleton mesh, right? And then our collisions, right? And then some physics parameters, and then our world map. These are general, and then let's move on. After having these core systems, we can move on to which are some common rendering effects. It's our gbuffer rendering path, and we often implement these features, rendering the lighting and making the shadows look good. After this rendering, its CPU consumption, isn't the overhead too much? Things like these. And specifically, how should we render it? Our resistance scaling, some methods involving view frames and teeth are within our rendering pipeline. Okay, then within this performance profiling system, we will also explain to you later that we often use certain commands to check our CPU and GPU, and also where their bottleneck is located. Simultaneously, we will also look at our memory. This pool, not like saying some texture pool, or memory and object pool, or something like that. Isn't it too big? Our computer on the client machine, can it handle this performance analysis part and this collision? Right, that is our collision in physics. It's something that we often have to do. For example, when we deal damage, firing a bullet, and then how do we detect it and how do we constrain it, right? If there are no collisions in your level, we all know that it will make a bang. Then you enable gravity, and then it just drops straight down to the bottom, right? And then this human interface device, it's actually our arrow mouse, right? Maybe some VIR or controllers like that. Okay, let's go up another layer. Once we have the renderer, we can create some visual effects. For example, we can see complex particle systems, decals, some post-processing effects. This subsurface scattering effect we have. Subsurface scattering is used for things like smoothing out skin, the kind of light that passes through the skin, and then reflects after passing through it. That effect is called subsurface scattering for our PBR materials, etc. And then scene optimization, right? It means not rendering things that are invisible, only rendering what we can see. And these front ends are UI. G, right? It's just you. The things you can click on. It's some UI that you point to with your mouse. This is 2D UI, or inside a scene. Some 3D UI. Like when we usually say drawing cards or doing a lottery. It's done on this UI interface. And here is Google's animation. This animation is very complex, because in this 3A game, there is actually a role which is specialized in our animation TA. GameMode. It is responsible for doing these kinds of animation states. For example, crawling, combat, flying, swimming. How does that animation switch between? And how do you aim? Then this is the networking part. It's what we are doing. How to make a RA game, an MMO game, right? Actually, what we most commonly do is make single-player games. And then there's another kind, which is Steam, right? There's another kind, which is Steam. And there's another kind, which is our massive multiplayer online game. It's the type of online game we commonly see, right? Just these 3 modes. Actually, we usually call it stand-on in UE5, called a listen server and dedicated server. And our audio is actually just playing. Just play once. That's fine. When our audio is actually rendered, there is a position called audio TA, who specializes in audio. It's just adjusting this rendering. Things like procedural audio, etc. Actually, it's okay. And scripting, right? The gameplay technology we usually use, this is what we care about. It's our blueprint and Lua. These are all scripts. It doesn't involve C++ much anymore. It specializes in some higher level logic. So the blueprint and C++ need to cooperate and divide layback. It's for a lot of repetitive, simple tasks. We use blueprint for that. And the code of the underlying framework. We all use C++ to write. Okay, and then this actually. We have objects in UE5. There are static objects. There are PUN, actor, and things like that, right? This place actually has some objects. Yes, and actually the world transfers in. It's about transferring the world over. Things like switching level. And some messages too. These are message bars. A message bar means that we will create a message box that is pushing the messages inside it. Then everyone goes into their message box to get their own messages, to complete the corresponding tasks. So basically, this part is essentially what we, as programmers, as C# programmers, often focus on this intermediate section. And then up one layer, it's our designers and the engineers for technical design and blueprints. And we ourselves also need to pay attention to how our game is designed. This is a first-person perspective game, a third-person perspective game, or it could be a fighting game, or it could be a racing game. So how do we design? How to involve its movement, its interaction with the scene, and so on. And then the dedicated rendering for this game. Are we going for a realistic style or an anime style? Actually, in our case, generally, making photorealism with UI is very doable. As for 2D art, most of it involves modifying the pipeline, etc. So it's relatively more complicated. And the game camera over here actually is, because we are in reality, can only be viewed through our screen. We want to call it HUD. This headset, things like a viewing device, to look through this screen. So there is also a 3D to 2D process. From what angle do we actually look at it? Actually, this is a bit like a camera. So we have a game camera here, and our artificial intelligence is actually AI. But AI is not a large model. This AI is called a behavior tree AI. It simulates various options in the scene, and based on certain situations. For example, I have an AI. I'm going to be a warrior. Warrior, AI. I need to deal damage. I am a nurse, AI. I need to heal my teammates. Then it will base its actions on the information it collects. Writing a structured data like this into it. What kind of decisions to make? In what situations? And do it like this. Of course, we can also use this large model to integrate it and make some RTS decisions, like operations or something similar. But this area should currently be. It should still be relatively on the market. That advanced thing has not completely established a generalized promotional technology. Okay, going up to our weapons, props, vehicles, these puzzles, these things. And actually when we make game, the most important thing is to focus on higher level mechanics. If we make indie games, we are individual developers, okay? So this general engine architecture, we've basically covered. And then in the next section, we'll move into officially entering the concept within UE5. These fundamental concepts. Okay, thank you everyone.